Hi folks, we're going to keep going with adding and subtracting fractions for rational expressions. I'll take you on a little trip down memory lane and we'll look at when you first learned how to add and subtract fractions. And it was probably a little bit more difficult than multiplying and dividing because you had to find a common denominator. So we'll take a look at doing this with some numbers first. So 5/6 plus 2/9. You have to find a common denominator. Ideally the lowest one. So 6 and 9, lowest common denominator is going to be 18, and 5/6 is 15 over 18. This will give us 4/18, gives us 19 over 18, or if you prefer as a mixed number, 1 and 1/18. It's been so long, though, that you've probably forgotten how it is that we found lowest common denominators to begin with. So I know certainly how I was taught in elementary school was that you should factor the first number on the bottom, so the first denominator. 6 is 2 times 3. You should factor the next number on the bottom, which is 9, becomes 3 times 3. And this, I think, was the first time that I ever saw Venn diagrams, was that they shared a common factor of 3. So this 3 was shared by both of them. 6 also had a factor of 2, and 9 had another 3 in it. Now, how do we get the number 18, our common denominator, from all those? Well, if we multiply through all the numbers that exist here in this little Venn diagram, we get 18, which was our lowest common denominator. Okay. It works out a little better than just multiplying 6 times 9, which also gives you a common denominator, but not a low one. You'd end up with 54, which is needlessly large. Okay, then here was the next part of the puzzle. You had 5/6 plus 2/9, and you said, I really need to turn this into a denominator of 18. So with a 6 on the bottom, I need to multiply by 3. And since I'm multiplying by 3 on the bottom, I need to do that on the top as well, because I can't just change the value of this fraction. All I'm allowed to do is change what the denominator is and what it looks like. 2/9, again, I need a denominator of 18. So that means multiplying by 2, because 2 times 9 makes 18. And since I do it on the bottom, I do it on the top as well. That's how we got to this 15 over 18 plus 4 over 18 gives us 19 over 18. I'm not advocating that you go back to doing your basic fractions that way, but I am saying that there might be some payoff in looking at that method of finding lowest common denominator when we do fractions that involve variables as well. That brings us to adding and subtracting rational expressions. So as per usual, we're going to do some factoring. We're going to factor the bottom of each expression. We'll state non-permissible values. So those are the values that cause division by 0, which we know is strictly forbidden. And we'll find a common denominator. Okay? And we'll find the lowest one that we possibly can. Otherwise, it's going to be really hard for us to simplify. We'll convert each expression to this common denominator, so lowest common denominator, and combine the terms on top, because that's what happens when you add and subtract fractions. You get a common denominator, and the bottom stays the same. You add and subtract the top. And we'll simplify if that's possible. So let's take a look at this first one. We want to simplify 3x squared minus 8 over x plus 2 minus x squared minus 9 over x plus 2. It says factor the bottom of each expression. We're all factored. That's done. State non-permissible values. So we have x plus 2's on the bottom of each of them. What x value are we not allowed to have? That's right. Can't have negative 2. That's going to cause division by 0. Find a common denominator. Well, in this case, we actually already have a common denominator. So I can write this all over x plus 2. I have 3x squared minus 8. I'm just combining the top terms. And notice here that you're subtracting all of x squared minus 9. So show that by using brackets. Otherwise, you'd just be subtracting the x squared and not doing the right thing necessarily with the 9. I'll show every little step on the way. And that brings us to 2x squared plus 1 over x plus 2, with the restriction that x is not allowed to be negative 2. All right, in part B, we've got 1 over 6a squared, 1 over 2ab, 3 over 8b squared. So we've got all monomials in this case. First thing we want to do is state the restrictions, or the non-permissible values. So in this case, there's no x, first of all. A is not allowed to be 0, and b is not allowed to be 0. Pretty straightforward. All right, now let's ask ourselves, what do I need on the bottom so that they can all be the same? I've got a 6, a 2, and an 8. So numerically, I know that my LCD is going to have a 24 in it. That's the lowest common denominator between 6, 2, and 8. Next, we ask ourselves, what kind of a's am I going to need? And you look for the highest power that exists on each term. So there's an a squared. I'm going to need an a squared for sure. Okay, are there any bigger powers of a? No, that's the biggest I need. There's a b squared. I'm going to need a b squared then. There's no way that I can make that into something smaller than a b squared. Turn it into a b in this term over here. So we're going to all have to go up to this lowest common denominator of 24a squared b. Great. I'm just going to rewrite it, but with a little extra space so that I can create these lowest common denominators. Okay, now let's ask ourselves, I need 24a squared b. What do I need to multiply my first term by? I've got a 6 on the bottom, need to make it 24. I'm missing a 4. 6 times 4 makes 24. Great. I've got the a squared dealt with, but I do need a b squared. Since I did it to the bottom, I have to do it to the top. All right, the next part, I've got a 2ab. That means I'm going to need the number 12 to make it 24. I'm going to need another a to make an a squared, and another b to make a b squared. Do it on top as well. Lastly, I've got 8b squared on the bottom. That means that I have to multiply by 3 numerically. And I also need an a squared. Great. Let's multiply each of those. Gives us 4b squared over 24a squared b squared. That's good. That's the denominator I wanted. Minus 12ab all over 24a squared b squared. Good. Oh, they have a common denominator. And that's by design. That's what we've been trying to do. Okay, then we end up with 9a squared over, again, the same denominator. Now that we've got the same denominator, we can simply collect our numerators. So we have 4b squared minus 12ab plus 9a squared all over 24a squared b. Let's see if we've done all the steps. Factor the bottom of each expression, didn't have to do. State non-permissible values, yep. Find a common denominator, did that. Convert each expression to its common denominator, that's right. Combine the terms on top, yes. Simplify if possible. So that means factoring the top and bottom and seeing if there's any opportunity for reduction of fractions. Okay, the top of this is a trinomial. It turns out to be a perfect square trinomial. It's 2b minus 3, or rather, minus 3a all squared. And this is 24a squared b squared. That's great. It's in its most sort of elegant format. But there's no opportunity here for us to reduce or to divide anything out. Okay, so that's as far as we can go with it. But it does look nicer than it started out with. It's a single expression now. And of course, we've got these restrictions. All right, let's look at one that has factorable expressions on the bottom, because this is where it tends to take a tiny bit more time, but it's no more difficult. So again, back to the instructions. Factor the bottom of each expression. Okay, I guess we better do that. So we have 3 over this trinomial that happens to factor to x plus 3, x minus 2. Okay. Minus 2 over this expression that happens to factor to x minus 2, x minus 1. Okay, I know that I better state my non-permissible values now. So x is not allowed to be either negative 3, it can't be 2, and it can't be 1. Great. Now, remember when we had the numbers 6 and 9. 6 was 2 times 3, 9 was 3 times 3. They shared a common factor. So we didn't have to go 2 times 3 times 3 times 3. We just had to find 2 times this shared common denominator, or shared factor rather, times 3 again. Gave us an LCD of 18. The same thing's going to apply when we look at our lowest common denominator up here. So the LCD is going to have to involve an x plus 3 and an x minus 2, no matter what. That's what's on the bottom at these two. In the next fraction, we've already got this x minus 2 dealt with in our LCD. All we need is an x minus 1 as well. So those 3 binomials should constitute our lowest common denominator and not be needlessly large. If we put x minus 2 twice, then yeah, we'd have a common denominator, but it would be bigger than what we really want. All right, 3 over x plus 3 times x minus 2. Oh, I want to build that common denominator that has an x minus 1 as well. So I'll just multiply the top and bottom by x minus 1. Okay, minus 2 by x, or rather over x minus 2, x minus 1. Again, I want to build that common denominator, and what's missing in this case is the x plus 3. Now we're ready to multiply our numerators, and our denominators for that matter. So I'm going to have 3 times x, 3 times negative 1. That gives me 3x minus 3 on top, and an x plus 3, x minus 2, and x minus 1. If you really want to, you can expand the bottom, but there's no reason to do so. It'll just take a lot of time and will not be of any use to you. Okay, in the next one we'd have 2 times x, 2 times 3. So 2x plus 6. Okay. Now it's pretty clear we've got this common denominator. We can put our two parts together, and we'll get 3x minus 3 minus brackets 2x plus 6 all over x plus 3, x minus 2, x minus 1. We should simplify on top. That's going to give us x and minus 9 all over x plus 3, x minus 2, x minus 1. Is there any further opportunity for simplifying, factoring, or reducing? No, there is not. X minus 9 can't be factored any further. So we're good here, and we have these restrictions. Now, it does seem a little bit painstaking to go through this. Once you get the hang of it, you should end up taking about, I don't know, 3 minutes maybe on a question like this. But our final answer looks a little nicer than what we started with. There are practice questions on 237 in the related handout, and there's a link to that just below.